So I'm going to walk you through on how to do an human health risk assessment. So human health risk assessment is just trying to know how much impact contaminated food we have on the humans if we ingest it. Also, there are some health risk assessment that deals with exposure part through inhalation and skin dermal, especially for soil, but we are going to look at for food only. So assuming you've gone to the field now and you've collected rice from market, rice and beans, and you're interested in knowing the lead concentration, cadmium concentration, and arsenic concentration. So all what you have to do is to now go to the market and collect the rice sample. Then you now go to the lab and measure PB, CD, and AS. So you're going to measure for rice and get the concentration for that, and measure for beans also and get the concentration. So you have values for all this here. So once you get this your values now, you can now go and do your human health risk assessment. So the human health risk assessment simply use this formula. This is our daily intake. So this is trying to tell you the concentration of those heavy metals you are going to take for eating the rice or beans. So this is the concentration of the metal. See, this is your injection rate. This injection rate is just how much of the rice you eat every day. This is the exposure frequency, how many times you eat the rice in a year. This is exposure duration. Exposure duration is how long will you be exposed to eating this rice. This is your body weight, and this 80 is simply does your is 365 multiplied by your exposure duration. So we've obtained our C from doing our lab test here. So what is left now is your injection rate. This injection rate now, you obtain it from survey. You go to each house and ask them how much rice they eat every day, and you record it for like 15 people or 30 people, then get an average quantity. So once you get the average quantity, maybe kilograms per day, let us say they eat 0.150 kilograms of rice every day. So you know that value too. The exposure frequency, how long are they exposed to eating rice? Most times they use 365, assuming they eat rice every blessed day. 365, but you can actually reduce this number, probably 350. Let us say they don't eat it every day. Then your exposure duration, normally US EPA say we should use 30 years for exposure duration, but some people use up to 50 years or 70 years, depending on how much time they'll be exposed to eating of rice. Then BW is the average body weight. The average body weight, you can also do a survey on this and get the average body weight of the people in your study area. Then this your 80. Your 80 is just 365 multiplied by your exposure duration. That is how you get 80. So now you can now go to your Excel sheets. These are our parameters we've already obtained from the survey and every other thing. Then this is a concentration of lead in rice, concentration of cadmium in rice, concentration of arsenic in rice, and these are also concentration of lead in beans, cadmium in beans, arsenic. So you've done the lab test and obtained this value. Now you can now go to your L3s. So the first thing we need to calculate is our daily intake. The daily intake, we are using this formula here. So you don't simply multiply your concentration of the heavy metal in the rice, the injection rate, how much of this rice they eat every day, then the exposure frequency, how many times do they eat this rice in a year, then the exposure to how long will they eat this rice. So once we obtain this, now this is the body weight and this is our 80. So we just simply do the multiplication. The multiplication, we are saying it like this now. We say that this is B5, which is concentration, multiplied by C5 injection rates, multiplied by D5, which is our exposure frequency, then E5 exposure duration. Then we have divided by the body weight, which is 62. Then this is our 80. I told you that your 80 is simply 365 days multiplied by what? Your exposure duration. That is how they came about this 10,095, 10,950. So once you obtain this now, you do that for cadmium and you do that for arsenic. So you've gotten your daily intake. So but we are not really interested in the daily intake. All we are interested in this is our hazard index. So the hazard index now, or the hazard quotient, sorry, the hazard quotient is simply your daily intake divided by the reference dose. This reference dose is more like a control parameter. So these are normally established by the national body or US EPA. So this is the concentration of lead in rice that may not cause harm. That is the reference dose. So we are dividing our daily intake all over the reference dose. The reference dose, you obtain it from standard. They normally give us that. So the reference dose for lead is 0.0036, cadmium is 0.001, arsenic is 0.003. So we are going to just simply divide your daily intake all over the reference dose, which is what we have here. This is our daily intake, this is our reference dose. Once we do this, divide this by this, we get this. We also do this and this, we get this. We do this and this, we get this also. So we've gotten our hazard quotient. The hazard quotient now, we've obtained that. Then after that, we can now obtain our hazard index. The hazard index is just the summation of the hazard quotient. Ideally, your hazard quotient should be less than 1 if there is no risk of consuming rice with lead, if there is no human health risk. So if you have hazard quotient less than 1, so there is no risk of consuming that rice with that amount of lead concentration. That is what we are seeing from our result. All of them are less than 1, so there is no risk of consuming the rice in our study area that has lead concentration that we measured in the lab. The one that has the highest risk was probably arsenic, but was still less than 1. But now we need to get our hazard index. The hazard index is just summing up all the hazard quotients. So what is the total non-carcinogenic risk from the multiple metals? So once we do that now, we are going to add all the hazard quotients. Once we add all these hazard quotients, we'll get an hazard index. So this hazard index is what is the total risk of consuming rice that has lead, cadmium, and arsenic. So we are saying that it's greater than 1, showing us that there's significant risk if we consume that rice that has this particular amount of concentration of this metal. So you see that we can't consuming that rice will actually cause an effect, a non-carcinogenic effect on our body. So once you've done the non-carcinogenic risk now, we are saying it's greater than 1. So once it's greater than 1, that means there's potential human concern. Then we can now check the non-carcinogenic risk. The non-carcinogenic risk, since we've gotten our daily intake, we'll just multiply by this our cancer slope factor. This cancer slope factor. The cancer slope factor is also given to. This is for lead is 0.085, for cadmium 0.38, this is 1.5. So we simply have to go and do that computation now. We know our daily intake, which is still the same thing as what we've calculated previously. Then we know our cancer slope factor. Once we multiply these two, we get the result here. We also get the result here, and we get the result here. Similarly to our hazard index that we added all the hazard quotient, we can also add the total, or we'll call this incremental life cancer risk, which is add all the old target cancer risk. Once we add everything together, we can get the total cancer risk from consuming rice with that metal, and we see a value of 0.00004. Now we have to now compare it with our accepted range. The accepted range, it has to be, for you to have non-carcinogenic risk, your value obtained from your computation has to be less than 1 exponential minus 6. That is the safe bound. Within this range, you have suspect. It's kind of acceptable, but you should just be careful. But if it's greater than 1 exponential negative 4, that means it's no more acceptable. So you have significant cancer risk. So we compare our value against this 1 exponential negative 4 and see what we obtain. We see that this now is actually greater than 1 exponential negative 4. If we'll go to scientific, so you see that it's greater than 1 exponential negative 4. So this we actually cause significant carcinogenic risk if we consume rice with this amount of concentration of lead, cadmium, and arsenic. So that is how you do your human health risk assessment.